In today's note, we are going to look specifically at the factored form of a parabola. So in the last week we've looked at, or in the last lessons we've looked at the vertex form of a parabola, and we're going to be looking at another form, which is the factored form. Now this is the exact, it still represents a parabola, it's still a quadratic, it's just in a different form and it gives us some different information. But in the end, it's still going to be a quadratic. So our general form for our parabola in factored form is y equals a times, and then in brackets, x minus r times x minus s. So this is the factored form of a parabola. The a value again controls the direction of the opening as well as the step pattern. So this is the exact same as what we saw in the vertex form. Right, that a value, that first number that we saw, that multiplier, or that number that was being multiplied, that controls the direction of the opening. Right, again, positive opens up, negative opens down, and it tells us the step pattern, or that 1a, 3a, 5a pattern. The new information that we get from the factored form comes from the r and the s values, or these two values in our equation. And these values, or more specifically the opposite of these numbers, so in this case, if we see a negative, it's actually positive. If we see a positive, it's actually negative. Similar again to what we saw in vertex form, right? Inside the bracket, the number with the x, we took the opposite of that. Same idea here. We're taking the opposite of the numbers we see in the brackets. And those numbers tell us the zeros, or x-intercepts, or roots, right? So those zeros, or those numbers, tell us the x-intercepts, or where this parabola or quadratic crosses the x-axis. So in this case, we're basically going to have zeros of r and s, or whatever the values are, or if you want to label it as points, r comma 0 and s comma 0, because again, remember, an x-intercept, the y value is always 0. So, using that information, let's go through and let's try to pick out these key properties when looking at an equation. So in our first one, we have y equals 3 times x minus 3 times x plus 5. So our zeros, or roots, or our x-intercepts are the opposites of these values that we see in the brackets. So in this case, I see a negative 3, so in actuality, it's actually positive 3. And I see a positive 5, so that actually means a negative 5. The y values in this case are always 0 because it is the x-intercept. The direction of the opening, actually let me just underline these so we see where it comes from. The direction of the opening comes from the a value, in this case the 3, or the first number that we see. In this case it's positive, so that means it opens up. Our step pattern also comes from that a value. Remember, it follows the general pattern, actually right off to the side, 1a, 3a, 5a. So if I plug this a value in, 1 times 3 is 3, 3 times 3 is 9, 5 times 3 is 15. So there's my step pattern. Moving on to the next example, y equals negative times x plus 2 times x plus 6. So we can see the two numbers in the brackets. We're going to have two x-intercepts. So in this case, x plus 2, so because of that plus 2, it's actually minus 2. So minus 2, 0. Another plus 6, so that's actually minus 6 and 0. So there are two x-intercepts, the opposite of those two numbers. The direction of the opening, I don't see a number, but I see that negative in front, so that means there needs to be a negative 1 in front of my bracket. In either case, because it's negative, that means it opens down. I need to know that it's a 1 because when I use this pattern, the 1a, 3a, 5a, if I plug in negative 1, 1 times negative 1 is negative 1, 3 times negative 1 is negative 3, 5 times negative 1 is negative 5. And there is my step pattern. For the last one, same thing, right? Look inside the bracket for the zeros. So negative 2, 0. Oh, sorry, not negative 2. I caught myself in the common mistake. Because we see a negative, it's actually positive. So 2, 0 and negative 8, 0 are my two x-intercepts. The direction of the opening, again, I get from the sign from the first number that I see. So there should be a number out front. I don't see anything, but I also don't see a negative. So because I don't see a negative, that means it has to be positive and it opens up. Because I don't see anything, I have to assume that it's a positive 1. So for my step pattern, 1 times 1 is 1, 3 times 1 is 3, 5 times 1 is 5. What we can do with our factored form is we can actually find the vertex of our factored form, and if we needed to, we could rewrite it as the vertex form as well. And that is because the zeros or the x-intercepts, they're going to be on equal side or equal distance from the vertex. Right? If you remember the parabolas that we've drawn, they've been symmetrical or the same on both sides of the vertex. So the x-intercepts, if we have two of them, are going to be equal distance on either side. So let's start off. If I'm given the equation y equals negative x plus 2 times x plus 4, the two zeros are negative 2, 0, and negative 4, 0. So I have a graph here below, so let's go through and actually plot those 2 points. So negative 2, 0, negative 4, 0. Because this is a parabola, right, these 2 points have to be on either side of the vertex. And because they're equal distance apart, we should know, or we should be able to tell, that our vertex has to be somewhere along this axis. Right? Or you could think of the axis of symmetry. The reason that the vertex has to be somewhere on this is because this is right in the middle of my 2 points that I'm given. Right? And again, we know the parabola is symmetrical. If we wanted to write it, x equals, in this case, negative 3. So we know the vertex has to land somewhere in that middle point. So to help us find the vertex, again, we want to find the x value first. Right, so in the middle of the two zeros, so we're finding the x value. So in this case, x equals negative 3. If we couldn't reasonably tell what the middle is, we can find that by using this formula. X equals r plus s, or basically the two values that I have. Right, so my two roots, and then we divide it by 2, or basically we're finding the middle or the average of those two numbers. So in this case, negative 2 plus negative 4, all divided by 2, we get negative 6 over 2, we get negative 3. So that's the same thing we just found. Because this one was nice, we could easily tell the middle. We didn't need to use this formula. In some cases you may not need to, but if you don't have a graph to use, then you can always use this formula. The next thing we want to do is basically take this middle value, or this x equals negative 3, and sub it into the equation for x and solve for y. So if I have my general equation, y equals negative x plus 2, x plus 4, I'm going to replace all the x's with negative 3. So negative 3 plus 2, negative 3 plus 4, and now I'm going to go through and solve. I'm going to leave the negative out front. Negative 3 plus 2 is negative 1. Negative 3 plus 4 is positive 1. Negative times negative 1 is positive. Positive 1 times positive 1, we get 1. So this means that when x equals negative 3, y equals 1, so therefore my vertex is going to be this middle value, negative 3, and this y-intercept, or this y value of 1, so that's my vertex. I can plot that point right there, negative 3, 1, and if I want to complete the rest of my parabola, I can use my step pattern to help me fill in the rest of the points. So again, our step pattern is 1A, 3A, 5A. A, we know, going back up to the equation, is -1. So if A equals -1, 1 times -1, 3 times -1, 5 times -1. And then I can just solve each step. So -1, -3, -5. And that is my step pattern, which I can use to label the next points. So I go over 1 or shuffle to the right 1, go down 1. I already have a point, my x-intercept. Good. So far we know that everything seems to be working. I'm going to take 1 step over again and go down 3. There's my next point. I can do the same thing on the other side, or I can use the idea of symmetry to know that it just needs to be there. And then finally, the last point or the last step that I have, go shuffle 1 to the right, go down 5, 2, 3, 4, 5. I can repeat the same thing on the other side, or I can use symmetry to understand that that's where it has to be. Once I have all my points, I can connect all the dots. And there is my parabola. If I wanted to as well, I can rewrite this in vertex form equation. And we'll look a little bit at another example of this later. I can write this in vertex form because we know a x minus h squared plus k. I know my a value from this form is -1. X is just going to stay x minus h. So minus the h value of the vertex. So minus -3 or plus 3 squared plus k, which we know is 1 from our vertex. So plus 1. So we can also come up with our vertex form once we've graphed our parabola. So moving into some more examples, I'm going to go through a couple of them. So the first one, again, same idea as the example that the examples we just did, right? Direction of the opening, so a little bit of reverse direction of the opening is that a value. So in this case it's negative, so we're opening down. Our step pattern, remember, follows 1A, 3A, 5A. So in this case, 1 times -2 is -2, 3 times -2 is -6, 5 times -2 is -10. Our zeros come from the opposite of what we see. So in this case, +1 and -3. So that's another way you can write your zeros. You can either write them as points or as just the two values. Moving on to the next one. Again, the negative out front, so it opens down. It's an invisible 1, so it's a -1. So we plug that a value into our pattern. 1 times -1 is -1. 3 times -1 is -3. 5 times -1 is -5. To get our zeros, we look at the numbers inside the bracket and we take the opposite. So -2 and -4. Finally, for the last one, same idea. I'm looking for the number in front. I don't see anything, so I have to assume it's a +1. I don't see a negative either. So because it's positive, it opens up. Plug that 1 into our step pattern, and we get 1, 3, 5. Our zeros, again, are just the opposite of what we see, so -2 and +2. So those are our two zeros or x-intercepts. What we're going to do next is basically take those three quadratics or parabolas that we just looked at and calculate the location of the vertex for each. And then we're going to sketch them later on to another graph. So I'm going to work through the first two, and then I'm going to pause the video on my end. I suggest you pause as well so that you can try the last one on your own. So if you keep watching the video, it's not going to look like much of a change. It should just be an instantaneous switch over. But when I let you know, I recommend pausing the video to try the last one on your own. But before we get into that, I will walk through the steps again. So y equals -2 times x minus 1 times x plus 3. If we want to find the vertex, specifically we start with the x value. We can do r plus s, or our two roots, divided by 2. In this case, for the first one, our two roots are 1 and -3. So 1 plus -3 divided by 2 equals -2 over 2 equals -1. So I know the x value of my vertex has to be -1. So my vertex so far is going to be -1 and something else. To find the y value, I have an equation where I can plug that x value in. So I'm just going to rewrite this equation of this quadratic, and then I'm going to plug in the x value. So instead of x, we have -1 minus 1 and -1 plus 3. Y equals -2 times -2 times +2. And this just becomes a calculation. Even the last one you could have done entirely on a calculator if you wanted to. But -2 times -2 is 4, times 2 is 8. So that means my vertex has the y value of 8. So in the end, the coordinates of our vertex are -1 and 8. From there, if we wanted to graph it, we could plot the vertex, plot our x-intercepts, and use the step pattern to find any other points. For number 2, same idea. Find the x value first. Because we don't have a grid yet, or we're not graphing them, I'm just going to take the two x-intercepts. So in this case, it's the opposite of what we see. So -2 plus -4. We're going to divide that by 2 to find our middle value. So we get negative. Let me actually just kind of keep the same format. Shift everything down 1. So we actually, the formula is r plus s divided by 2. Which we have the -2 plus -4 divided by 2, and we have -6 divided by 2, and this simplifies to -3, or x equals -3. So we know the x value of our vertex has to be -3. And now our goal is to find the y value of that vertex. And the way we do it, again, same as last one, we take our formula for this quadratic. So -x plus 2 times x plus 4. And we plug it into the equation, or this x value into the equation. So everywhere we see an x, we plug in -3. So -3 plus 2. -3 plus 4. We can simplify it. Then don't forget the negative out front still. -3 plus 2 is -1. -3 plus 4 is +1. And in this case, we get +1. So in this case, our vertex is going to be -3, +1. And again, the coordinates of vertex, -3, +1. We found the x and the y value. If we wanted to graph this, we could. Finally, the last one, this is where I'm going to pause it. I suggest you do the same and try this one on your own. You will see the answer pop up shortly. But again, please pause the video, try to do this one on your own. If you're still a little bit confused, just hang on for a second and you'll see the answers pop up. So here we see example 3 all completed, and you should have found that you got a vertex with coordinates 0, -4. So again, we found the middle value of the x, we took that value, plugged it back into the equation to solve for y. Those two answers were our two coordinates. Our goal now is to graph these three equations. So we're going to use the information that we have to graph them. So the first one, going back up, we see y equals negative 2 x minus 1 x plus 3 times x plus 3. So we know our two x-intercepts, and even from the table, are 1 and negative 3. So I'm going to plot a point at 1 and negative 3. Those are my two x-intercepts. I need to know my vertex. So looking again at the top one, I see my vertex is negative 1 and 8. So I'm going to plot that point, negative 1 and 8. Now, if I wanted to just sketch this, I could just connect the two lines and hope for the best, but I do have enough information to accurately plot the rest of it. And that comes in the key part of going back up. We see that a value. Or if we go back up to our table, we have this step pattern. So that step pattern tells us negative 2, negative 6, negative 10. So if I start at my vertex, I go over 1, that means I go down 2. There's a point. I can repeat that pattern on the other side. And for my next point, I should have to go over 1 and down 6, which I do. I get to my vertexes that are already there, or my x-intercepts, sorry, that are already there. And my last point, or last step, go over 1, down 10. And I end up down here, and I repeat the process on the other side, or just remember that it's symmetrical. I'm then going to connect all of my points. I'll label this equation 1, and here we have a good representation of that quadratic or that parabola. For the second one, I'm going to start with my two x-intercepts, or my zeros. So I see in the second one over here, my x-intercepts are negative 2 and negative 4. So I'm going to plot those two, negative 2, negative 4. I see the coordinates of the vertex are negative 3, 1. So I'm going to plot that point. And now I just need my step pattern. So going back up, I can see my step pattern is right here. That negative 1, negative 3, negative 5. So over 1, down 1, which is my x-intercept, so good, we're following the right pattern. Over 1, down 3. Repeat that same process on the other side. Then over 1, down 5. And I can repeat that or use a symmetry for the other side. Connect all my lines. We'll label it number 2, and there we have our second parabola. Lastly, for our third one, again, I have my zeros here, so my x-intercepts, so negative 2 and 2. So I'm going to plot those points, so negative 2 and 2. I have the coordinates of my vertex here, 0, negative 4. So 0, negative 4. And I could again just roughly draw what it looks like. Oh, so it looks something like that. But I have my step pattern going back up to the table here. So I can plot or use the step pattern to figure out the rest of my points. The step pattern is 1, 3, 5. Positive in this time, so I'm stepping up. So over 1, up 1. I can repeat that on the other side. Over 1, up 3. Those go to my x-intercepts. Over 1, up 5. And there is my parabola or quadratic. The last example we're going to look at is something similar to what we covered with the vertex form. So here I want to determine the equation of a parabola given the x-intercepts of 2 and 8 and passes through the point 4, 12. So we've seen something like this with vertex form, but we can't use the vertex form in this case because we're not told the vertex. We are told the x-intercepts though, so if we're told the x-intercepts, there's a good chance that we should be using factored form, which is again y equals a x minus r times x minus s, where r and s are our two roots. So what this equation tells us is that r equals 2, s equals 8 from the x-intercepts, and we're also told an x and a y value. So we're told that one point is 4 and one value is 4, one value is 12, and in a point that's the x and y. So with all that information, I can substitute all of that in and solve for a. So again, similar to what we did in our vertex form lesson. So sub r, s, x, and y into the equation to solve for a. So taking that equation, y equals a, x minus r times x minus s, I'm going to plug in all four variables. Y is 12, a we don't know, x is 4, minus r, which is 2, times x, which is 4, minus s, which is 8, and I've plugged everything in. What I'm going to do now is simplify, so I can simplify those brackets. So 4 minus 2 is 2, 4 minus 8 is negative 4. So in this case, again, still simplifying, a times negative 8 equals 12. If I want to get a by itself, I have to divide both sides by negative 8. One side will cancel out, and I'm left with 12 over negative 8 equals a. If I want to, I can simplify this. Divide both sides by 4. I get negative 3 over 2 equals a. Now that I know my a value, I know my r and my s value, I can rewrite my equation. Y equals negative 3 over 2 times x minus 2 times x minus 8. And this is my factored form equation. So again, same idea, plug in. We should be given enough information for this specific form, plus a point to fill in for x and y, and then you solve using algebra for the a value, and then we can rewrite our equation with the correct variables filled in. But again, the main thing here is looking at factored form and just understanding what information the factored form gives us, how we can find the vertex, and how we can plot this graph.